So now moving on to more problems with isosceles triangles. We are being asked to find all the variables in this problem. And this has some similarities to the last problem we just did. We see that this smaller triangle here is equilateral. So that automatically tells us that all three sides are equal, that all three angles are equal to 60 degrees. So we can write in the angle measurements there, and it tells us that y is equal to 60 and w is equal to 60, and this other unlabeled angle is equal to 60 degrees. So that leaves only angles x and z. Okay, well, let's take a look. Can we figure out either of them already? And I think you'll notice that z and 60 are linear pairs. Okay, so this is a linear pair. And because these two are linear pairs, 60 plus z equals 180 degrees. They're supplemental to each other. That tells us z is equal to 120. So z is equal to 120, and that only leaves us x. Well, how are we going to figure out x? We know z is 120, but we haven't yet used the fact that this triangle on the right here is also an isosceles triangle. Okay, because we have two sides equal, that side and that side. So that means that the two base angles are equal. One of them is x degrees, and the other one is not labeled up here, but we can put it in as x, because we know it's got to be the same as this base angle. So now we've got a triangle where we've got one of the angles 120 and two of the angles x, and we know that by the triangle sum theorem they sum to 180. So let's come up with an equation. 120 plus x is equal to 180 degrees. And we can solve for x. 120 plus 2x is equal to 180. 2x is equal to 60. X is equal to 30. So we are able to then determine that x equals 30 degrees. So x is equal to 30. So that would be our solution to the first problem. Okay, so we're using both the equilateral property as well as the isosceles property, and then the linear pair postulate. Let's go on to problem number 2. So in problem number 2, we have to solve for 4 of the angles. We're given a lot of stuff here. We're told that we've got a right angle, and w is a linear pair to a right angle. Well, we kind of know what that means. We know that that means w has got to be 90 degrees as well, right? We can just write that in even as we're looking at it. We're also given two congruent angles here near the top of this triangle, and it's also clear that we've got two congruent sides, so that this is an isosceles triangle. Okay, well, that's a lot of information, so let's start chipping away at this problem. Sometimes you can't exactly just jump in and say, oh, I know what y is, I know what z is. What you've got to do is you've got to slowly fill in the gaps of what you do know, even if it's not one of the angles you're looking for. So let's figure out, can we figure out something that may not be exactly the angle, but might help us? Well, let's take a look here. 150 degrees and x degrees. Okay, this is a linear pair. And actually, that does tell us what x is, right? X here is equal to 30 degrees, because it's a linear pair. So we can write 30 in here. That now tells us that this vertical angle over here is 30 degrees as well. Now, that may not directly give us something, but it may help. So this angle is 30 degrees. And this angle is equal to this angle, but we don't know what this angle is, right? But we do know that this angle is that this bigger triangle is an isosceles triangle. Notice this side is equal to this side. So if the base angles of an isosceles triangle are equal, then this would be one of the base angles, and so would this be a base angle. This unlabeled angle on the right is also equal to 30 degrees. So it's really important to notice that we've got several triangles inside of each other, right? The one that I'm going to fill in blue is the one we just looked at. This triangle here okay, is an isosceles triangle because it has two of its sides congruent. And this being one of the base angles means that this angle is also congruent. It's also 30 degrees. Okay, good. So can that help us with one of the other angles? Yes, it helps us with z, doesn't it? Because 30 and z are another linear pair. We have another linear pair over here, which makes, just like this linear pair here was 150 and 30, so we've got z equals to 150 over here. So we have z equals to 150, and the only thing we've got left to figure out is y. Okay, what is y degrees? It's this angle here. Can we figure it out? Yes. Okay, we can, because now we're going to look at this smaller triangle. Which I'm outlining in a lighter green color. Okay, and that smaller triangle is a right triangle. It has a right angle, it has a 30-degree angle, and then it has angle y. Okay, so angle y plus 90 plus 30 is got to equal to 180 because of the triangle sum theorem. And when you solve this equation, you will find y is equal to 60 degrees. Okay, so then y equals 60 degrees. Was there another way I could have done this problem? Absolutely. I could have looked at the dark blue triangle here. Okay, and notice that these two angles are 30 degrees, and this entire angle up here is the third angle. Using the triangle sum theorem, 30 plus 30 is 60, and then another 120 degrees would give us 180. So this entire angle up here is 120 degrees, and we're told that this must be an angle bisector because it's bisecting that 120 degrees angle into two smaller angles, which would mean each one of these has to be 60 degrees, which would also have given us y equals 60. So we could have done this many different ways, but the only important thing is that no matter which way we do it, we need to do it correctly. We need to be sure that we're not making any kind of silly mistake, and we should check to make sure that regardless of how we do it, we get the same result.